I'm Anil Kumar, sharing with you a video on polynomials characteristics. I'll discuss in part 1 of this video the following topics. We'll see what is degree and leading coefficient for a polynomial, understand its behavior, number of zeros and degree relation, number of turning points and zeros relation. We'll graph polynomials. Polynomial equation from graph will be written, and then we'll discuss some objective type papers. The next video will be called part 2, in which we'll see how to find the first difference in polynomial equation from data, and we'll discuss transformation in details. Now, the type of questions which can be answered after this video are seen here. You'll find many objective type questions. I have a sample of objective type questions here for you. You can have a look, pause the video, copy some of them, and these all can be answered at the end of this video, right? So let's go through some of these questions. You can actually pause and copy these questions, right? So these are a few questions to share. Okay, so I hope you got a good look at it, right? So that was the first question. Well, this is another paper, some more questions for you to see. So we'll be in a position to answer all such questions after going through this video. And also we can discuss how to get the equation of a polynomial from its graph like this, or in objective type match the equation with the given graph. So let's begin with degree and leading coefficient and the end behavior of a polynomial. In general, a polynomial function could be written as p of x is equals to an x to the power of n plus an minus 1 x to the power of n minus 1, so on. Let's say a2 x squared plus a1x plus a constant a0, right? Where n, which is the exponent, belongs to what? These are natural numbers or whole numbers, you can say, because it can be 0 also, right? So these are whole numbers. They cannot be fractions, right? And the coefficient an, let's say, belongs to real numbers, correct? That is what a polynomial is. So what I'm trying to say here, that if n is negative, that is to say, let me write down here what are not polynomials to begin with. Not polynomials will be if I write 1 over x, since here x is to the power of minus 1 or square root of x or something like sine x or e to the power of x or say 2 to the power of x. These are not polynomials, correct? So you get a point. We have polynomials which are kind of like this, and n, the highest power is the degree. So if you are given a polynomial in an equation form like this, in that case degree is the highest exponent. For example, if I write f of x is equals to 2x cubed minus 3x to the power of 5 plus 4x minus 1, in this particular case, what is the degree? Well, normally we'll write a polynomial with highest degree first, but in test papers you will notice that at times they mix them up, right? So the answer here is, you look very carefully, degree is 5. Correct? We also say, well, this polynomial has odd degree, or it is odd degree polynomial. Is that okay? Now, the second important thing to look is the leading coefficient. an, which is the coefficient of X with highest degree is called the leading coefficient. And in our example, leading coefficient is? Leading coefficient is not 2, but minus 3. It is minus 3. You get an idea, correct? So those are the answers for the given example. So degree is 5. It's odd degree function with leading coefficient of minus 3. Now, we have an example here. We'll now see the end behavior. We'll talk about end behavior now. End behavior really means if x approaches negative infinity, then what happens to y, right? Or if x approaches positive infinity, what happens to y? So that is kind of end behavior. You could always find end behavior of a polynomial from its degree and leading coefficient combination, right? So let me take some examples here, and then we'll take up a concrete example from some test paper, right? Okay, so let us assume that an is positive, right? So leading coefficient we're talking about. So if I take leading coefficient an, which is greater than 0, that means positive, then the graph will be right side up. The graph will be right side up, kind of like this. If the leading coefficient an is less than 0 or negative, then the right side will be down. So the graph of the polynomial will indicate right side going downwards. So that is one part which you have to look into. The second condition which we look into is the degree, right? If degree is even, so let me write down here. Now we will analyze. So we have seen the leading coefficient. Now we will see what is the effect of degree. So if degree is even, then both will face same side. Same side. So if right side is up and we have even degree, then same side. Do you understand what I'm trying to say? Same side. This is same side and behavior when degree is even. So this is when even. However, if the degree is odd, let me use another ink here. If the degree is odd, then they will face the opposite ends. That is to say, the function will be kind of like this. Opposite this means kind of like this. You get an idea, right? So that is opposite ends. So if I have a function, let me draw like this, some function like this. So that means that it is odd degree. Since we have opposite ends and leading coefficient an is less than 0, negative. Do you understand? On the other hand, if I have a graph of a function which is, let's say, kind of like this, it really means that the function has leading coefficient an as positive and this function is even. You get an idea, correct? Odd and even. If I have an odd function here, I should be sketching it kind of like this. Do you get an idea, right? And if I have to sketch an even degree function with negative leading coefficient, it may be kind of like this. You get an idea. Correct? So that is how it should be. So let's take up an example here. So let me take an example here, right? Let's take up these examples. So from a test paper I've picked up, what do you say about this graph? Its leading coefficient and end behavior. So this is of a polynomial, a smooth curve without any breaks. Domain is always all real numbers. There are no asymptotes for this function, no sharp corners. All turns are smooth. Okay. Now what you notice here is that the right side is down. That means that the leading coefficient is negative, right? So here, let me write down about this graph. So what we have here is leading coefficient is negative, right? That is an is negative. Both are facing the same side, so it is even degrees, okay? Polynomial. Here, right side is up. That means an is greater than 0. It is positive. Opposite ends means that it is odd degree. Correct? So you can match the solution knowing this information about the end behavior from the graph, right? Okay. So let's move on. We'll get back to those sample test papers at the end of the video. Number of zeros and degree relation. Let's try to understand that part. So I think I have some example here. Okay. So first thing is, let's take up an example. If I say that I have a, let's take a very simple example. Let's say we have a quadratic function. Correct? So that means the degree is 2. The possible sketches for a quadratic function could be we could have a parabola kind of like this, right? We could have a parabola which could be kind of like this, or we could also have a parabola which could be kind of like this. There are these different kinds of scenarios. What I'm trying to show here is that for a quadratic function of degree 2, the number of zeros could be 2, 1 or none, right? So I could write that for this, the number of zeros, possible zeros, right? Number of possible zeros could be 2, 1 or none. Do you see that? So no zero, since it does not cross x-axis, correct? So no x-intercept. You get an idea. Now, if I take a cubic function, okay, so in that case, what type of graphs can you draw? Well, a cubic function has to cross the axis, so it will kind of go like this. Since, even degree function face same side. So when you're facing the same side, you can go from quadrant 2 to 1 without crossing x-axis. For an odd degree function, they face opposite sides. So they have to cross x-intercept. That means there is minimum 1, 0, right? Or you could have a cubic function which could be like this also. It could turn and then go, right? So here we have 2 zeros, or you could have a cubic function which has 3 zeros. So let me show that also for you. So for a cubic function, we definitely have 1 zero as minimum. We could have 2 zeros or 3 zeros, right? So these are the possible number of zeros. Do you understand? Now from this, you could actually conclude that if we have degree n, and if n is even, then can you tell me how many possible zeros can we have? If n is even, then possible zeros are 0, because they could go without any x-intercept, 1, 2, so on, till n. Do you understand? N degree will give n zeros, maximum. For degree, which is n but odd, for for example 7, the possible zeros will be at least 1, since it has to cross. Do you see that? 1, 2, till n, correct? So what you notice here, that for even, minimum number is 0 and maximum is how much? N. But for odd degree, minimum is 1 and maximum is n. Both maximum is n. Do you see that? So that is very important to understand. We might take a few examples from objective type question paper in this regard. Now we will discuss a relation between number of zeros and turning points for a polynomial. So I have taken up 3 questions from previous test papers. A is, write all possible number of turning points for a quintic polynomial. Quintic means degree 5. B, write all possible number of turning points for an octic polynomial, means degree 8. And C is, find the number of turning point for a polynomial with zeros -2, -1 of order 2, sometimes we say multiplicity, 0 at 2 with order 3, and at 5 with order 4. You can always pause the video, answer these test questions, and then look into my suggestions. Now in this particular video, we are going to also derive a formula which will relate number of turning points with number of zeros. So that is what the idea is. I'll write down the formula at the end of this part. Now let's begin answering these questions one by one. Write all possible number of turning points for a quintic polynomial. Now quintic means degree 5. Degree 5 means odd, correct? Odd degree. So when we are talking about odd degree function, well, we'll assume in this case that the leading coefficient an is greater than 0. That means right side is up. This is what we are going to assume for the time being. It could be negative, the graphs will be reflected on x-axis. Okay. For degree 5, we could have a very simple graph which could be kind of like this, x to the power of 5. Here, what do you see? 1, 0. However, at this point, the graph doesn't turn. It changes its concavity, and this kind of a point is sometimes called, or you say is called, point of inflection, right? So here concavity changes. Do you see that? But it is not a turning point, not a turning point, correct? This is important to understand. So minimum number of turning points, it says write all possible number of turning points. So we get minimum number of turning points is 0. So we get number of turning points. So we are writing the answer here. We just found that it could be 0. X to the power of 5 is an example. Now, the other situation could be that the graph turns once. So if I sketch a graph which, let us say, which turns. Now if it turns, it is going towards same side, but since it is degree 5, which is odd, it has to land up in quadrant 1. So that means it has to turn at least once more. You get an idea? So what you notice here is that odd degree function like degree 5 cannot have 2 turning points. Cannot have 1 turning point, since it has to again turn to land up in quadrant 1. So the next possible number of turning points is 2, not 1, correct? Example could be, we can say 1, 0 here at, let's say -4. So you could always write this function as x plus 4 to the power of, it's like a turn, we say 4 times this at x. So we have degree 5, and you see how it turns. Now, another possibility could be that we have a function. Let me just, now we'll not consider the equation, but the concepts. It turns and then it again turns and wants to turn again. Okay. Now, since it is turning, it is going towards this side. It has to make another turn to land up in quadrant 1. End behavior. Do you understand that part? Now, in this particular case, all are linear zeros. We have 5 maximum possible zeros. And the number of turning points is 1, 2, 3, 4. So, for a degree 5, all possible number of turning points could be 0, 2, 4. Do you notice all are even numbers? So, we have even number of turning points for odd degree. Very important to understand. Now, the next example purposely has been taken for even degree. So I hope you can write down the answer now. We'll again assume leading coefficient to be positive. Okay, so if I say an is greater than 0, right side is up, degree is 8, both same ends, correct? So if I move from here to there, I have to turn at least once. So number of turning point now cannot be 0 as it was last time. Minimum is 1. You get the idea, right? It could have 0 x-intercept. However, there is at least one turning point. Now, like last time, if this decides to turn once and then again, then we have to turn once more since we have to land here, right? So the number of turning points is 3, so we get 1, 3. And since it is 8, you can do the rest. It will be 1, 3, 5, and 7. What we notice is that we have odd number of turns. For even degree polynomial. Important concept. So if the degree is odd, we have even number of turns, 0, 2 to n minus 1. So the maximum turning point is always n minus 1, right? So we say maximum is n minus 1. Is it okay? Minimum is 0 for odd degree and 1 for even. Perfect. Now part C is we are given zeros. We say find the number of turning points for a polynomial with zeros at minus 2. So what we will do this time is we will first sketch. It's easier to sketch, count the zeros and then build a formula. Okay. So the number of zeros minus 2, let's say this is minus 2 for us, and the order if not mentioned is order 1, so we'll write in brackets. Then we have at minus 1 order 2, we'll write in brackets. At 2, let's say this is 2 for us, this drawing is not to the scale, order is 3, and at 5 we have order 4, right? Those are the x-intercepts or the zeros. Zeros will always have order or multiplicity. We sometimes call this as multiplicity, okay? So multiplicity 4, that means there are 4 zeros at the same point, correct? For once, we'll assume that the leading coefficient is less than 0. Now let's count the degree of this. So the degree should be how much? Count all the zeros with multiplicity, right? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. 10, that means even degree. Is that okay? So number of zeros should be odd, correct? That's one thing. Okay, let's try to sketch. Since we are assuming an to be negative, right side is down, right side is down. Even means both are down. Do you see? That's the concept we have learned earlier part of this video. 1 means it is going to cross, 2 means it is going to be reflected, 3 means like a cubic function, 4 means gets reflected. So we just sketch this, which helps us to sketch a very smooth and a neat graph. So we just say, well, this is my function. I'm just joining these lines. Do you see that? Do you see that? How? And then, perfect. This is your y-intercept. So at present we have a general function. If I know value, it becomes specific. Correct. Let's count the number of zeros. Simple. I mean number of turning points. So what are the number of turning points here? We have 1, 2, 3, 4 and 1 5. So number of turning points are 5. Now how do we get this without sketching? That's the whole. So we have the number of turning points here as 5. The formula here is you count number of turning points with number of zeros. So it is equal to number of zeros minus 1. Since if I have 2 zeros, I have to turn ones to get to them. And then we have to add even order zeros. Why do we add? Because at even order, you have to turn. Do you see that? So you have to add. So in our case, applying the formula, we could get turning points as number of zeros are 1, 2, 3, 4. Correct? 1, 2, 3, 4. Minus 1, which is number of zeros minus 1 plus even number. So we have order 2 and order 4. There's 2 are there. So 4 minus 1 is 3. 3 plus 2 is 5. Do you see how the formula fits in to give you the exact number without sketching? So you see how the formula fits in to give you the exact number without sketching, right? That's the beauty. So I hope you are learning as we move along. The video is a bit longer, but this is a very important concept. So let's go with it. Now here is how we are going to sketch few graphs. I have 2 examples from previous test papers, and I have purposely twisted some values to trick you. So be careful about it. All the graphs which I am going to make will be very rough sketches, but I am going to explain you the concept. You can always pause the video, take a graph paper and sketch them nicely. Okay, so we need to graph f of x, which is x times x square minus 1 times x plus 2 cube times x plus 5 to the power of 4. So we have taken all types of orders or multiplicities for different zeros, correct? Here the function is 2x plus 1 whole square times 1 minus x cube x plus 2 to the power of 4. Again, the idea is that the degrees are different kinds, so it helps you to understand how to sketch polynomials. Now let's first count the degree by adding these exponents since we are multiplying them. So 4 plus 3 is 7 plus 2, 9 and 1, 10. So 10. That means even, correct? Second thing is, let's find leading coefficient an. Basically, we have to check the sign. So if I multiply x, x, x and x, all are positive. We are saying it's positive. It does make sense. Now it's very also important to find y-intercept. That is, if I substitute 0 for x, I get, in this case, 0. Okay. So these are important things to consider whenever you sketch a polynomial. 3 things. Figure out the degree, and then whether it's even or odd. Figure out the leading coefficient, whether it's positive or negative, and the y-intercept. Y-intercept gives you the specific curve. Otherwise, you're playing with a family of curves. Okay. So 10 means even, and positive means right side up. So we know the end behavior, right side up. Even means both same sides. Do you see that? So we know the end behavior. So from these two, we actually get end behavior. Now we'll sketch. So this 0 is at 0. Now x squared minus 1. That's the tricky part. So what we'll do is we'll rewrite this function. Let me rewrite this function as, let me write down here. So we'll say f of x is equal to x times, factor it out, x plus 1 times x minus 1. Do you get it? And then we have x plus 2 cube and x plus 5 to the power of 4. That should help. So we have a 0 at a 0. Okay. So let's write down. Let me take a pen here. So we have a 0 at 0 and the order is 1. The order is 1. Then we have at minus 1. The order is again 1. Right. No need to write, but Then we have at plus 1, order is 1. Then we have minus 2. I'm writing all this just to explain you, no need for you to write, but the order is 3. Okay, 3. Then we have at minus 5, the order is 4. The order is 4. Since we know this behavior to begin with, we know we have to start from this side. Okay. 4 means the graph will bounce back. 3 means it will go like a cubic function. 1 means like a line, line, and line. Connecting these points, you get a very beautiful graph. So you have this function, right? So we'll have this going like this. Okay, that's not so good. And then let me take something else. Okay. And they will connect. So that could be a small turn like this, like a cubic function, straight line, straight line, straight line, and then move. So that becomes the graph for the first function. Okay, y-intercept being 0. Follow this procedure to sketch the next graph. Now here, can you tell me what is the degree? Degree is 4 plus 3 is 7 plus 2 9. So we have odd degree. Okay. Now what is the leading coefficient? an. Now you'll be surprised to see that I have switched this value. So it is negative because minus x cube will give me minus. So it is negative. Do you see that? It is not positive. So that's the kind of trick which you may see in the test paper. Note, it is not x minus 1. It is 1 minus x. Okay. Now, what is the value of your y-intercept? That is, find what is f of 0 equals to. Plug in 0 here for x. So you get 1 square, which is 1. And then you get 1 cube, 1 cube. Okay, that's simple. And then you get 2 to the power of 4. 2 to the power of 4, since we have substituted x equals to 0. Is it okay? So x is 0, these terms become 0. When you multiply, you get the value as 2 to the power of 4, which is 16, right? So the y-intercept is positive 16. Now let us sketch writing down our zeros. So the zeros are at, this one is at minus half. Let's say this one is at minus half. Its degree is 2. So I'm writing 2 here. This one is at plus 1. So let's say this is plus 1 for us, and multiplicity is 3, or order is 3. Then we have a 0 at minus 2. Let's say this is at minus 2. The order is 4. So 4 plus 2, 6, 6 plus 3, 9. That matches. Negative means right side is down. Negative means right side down. So we'll begin from here, or odd means opposite ends. Okay. It's good to sketch from left to right. So if I'm sketching from here, degree 4 means it will bounce back. Degree 2 means again bounce back. Degree 3 means it will go like this. Is it okay? So we just connect these points and sketch. So let's use this pen. So we could sketch like this and connect these points like this. Connect these points like this. Connect these points like this. And there you go. Y-intercept is 16 plus. So that is also a test. We know we are on the upper half with positive y value, so it should be correct. So that becomes the sketch of our polynomial. So I hope this helps you to understand how to really sketch polynomials. Now the last part is to find equation of a polynomial. So we are given a polynomial function here. You can pause the video, find the equation. The y-intercept is given here as, let me write down the value, f of 0. The y-intercept is given as f of 0 is equal to minus 33.75, correct? Now with that, it is too small. You can pause the video, answer this question, and then look into my suggestions, right? And here we have a 0 at 5 minus. Do you see that? Okay. Okay, let me give you the solution now. Let's say this polynomial f of x should be equal to a times, very important to write a, and let's begin with the zeros. One possibility is this is very flat, so it is at least order, will make it 4, not 2, right? So x plus 5 to the power of 4, because very flat. Now here's linear, we'll write this as x plus 2, linear means degree 1, and then here it is cubic, we can say x, this point is at 3, x minus 3 whole cube, correct? To find the value of a, we'll substitute 0 here, so we know f of 0 is equal to a times, if I write 0, you can write like this first, right? 0 plus 2, 0 minus 3 whole cube. Now we have f of 0 as minus 33.75, and here we have a times 5 to the power of 4 times 2 times minus 3, 27, right? I mean, we'll write later. So now you can use your calculator to calculate. Basically, a times 625 times 2 times minus 27 is minus 33.75. So a is equal to, both are minus here, minus 33.75 divided by this number, which is 2 times 625 times minus 27. Let me write minus here, and these minus cancel out, correct? So we need to use a calculator to calculate this. Here is the calculator. Let's calculate the value. We have 33.75 divided by, let me write in brackets, 2 times 625 times 27 equals to 1 over 1000. So it is 1 over 1000. So that's a good value. Okay. So we get our result, which is f of x is equal to 1 over 1000. See, positive, right side up, both same end, degree even, correct? So we have x plus 5 to the power of 4, x plus 2 times x minus 3 whole cube. So that becomes the answer for the given question, correct? So now let's move on, and there's something else. Okay. So we'll now discuss the objective type questions. Okay. So here is one of our test papers. You can look into these questions and answer. The first question here is, which of the following statements about a polynomial function is false? Well, the first one is a polynomial function of degree n has at most n turning points. Is it true or false? Well, the number of turning points is n minus 1, not n. So the first statement is false. Now, second one here is, if the leading coefficient of an odd degree polynomial function is positive, positive means right side up, then the function extends from the third quadrant to the first quadrant. That is correct. So the end behavior will be, it goes from minus infinity to plus infinity. So we have to see y goes from minus infinity to plus infinity. Part C is correct. Then we have the degree of a polynomial provides information about all of the following: the shape of the graph, the end behavior of the graph. We are talking about degree of the polynomial, right? Provides information about all of the following except this, except, right? Which one? So degree, does it tell you about end behavior? Let's talk about it. The turning points of the graph, yes, degree will tell you how many possible. The zeros of the graph, possible number of zeros, perfect. But the end behavior, degree cannot tell you. End behavior, leading coefficient decides. If the leading coefficient is positive, right side is up. Do you get the idea? For example, this graph, leading coefficient is positive, right side is up. Degree doesn't decide that. Okay. Now, the last question here is, which equation is a quartic function with zeros at minus 4, minus 1, 2, and 3? You can figure this out. right? So x plus 4 will, so this one, okay. Now we have to write the equation of the graph. We have a 0 at 4 and this degree is 3, correct? Leading coefficient is positive and we have a 0 at 1. So it will be x minus 1 times x minus 4 cube, correct? So which is this one. Then we have, what is a parent function of this? Parent function is x to the power of 4. Describe the transformations. Well, you can look into these questions, correct? Another one which I'll pick up for you is right here. I'd like you to match the equation now. We worked on it earlier. So there are 3 possible equations for the given graph. Since it is even degree, both side down, so we are looking, leading coefficient is negative, all are negative, right? Now, degree is what? The zeros you could count here is linear, cubic, 2, right? So it is 2, 3, which is 5 and 1, 6, okay? So we are looking for at 4, square, minus 4 square, that works. At 0 cube, that works, perfect. And here a linear, perfect. So that is your right answer. Now for this one, we're looking for linear at 5, cubic, and linear at 4, right? So x minus 4 with a linear factor, which is right there, becomes your answer. So I hope that helps you to answer such questions. So whatever we have learned is actually pretty useful. Here are 2 more questions which you can look into and answer yourself. So I hope you find this video interesting. We'll now take up part 2. It's kind of a review for what you have learned. Thank you and all the best.